Hello everyone. In this lesson, we are going to dive into the fascinating world of complex number. By the end of this video, you will understand the basic concepts, learn how to perform operations with complex numbers, and solve questions involving equal complex numbers. Let's get started. The first thing is form of a complex number. We normally represent a complex number with small letters Z, W, S, T, etc. Let us consider a complex number and it is in the form of a plus iota b. So this complex number is consisting of two terms. The first term is known as the real part. The second term, which is with the iota, we call it as imaginary part. Basically, imaginary part will be the coefficient of iota. If we consider examples for any complex numbers, then we can understand the real part of z is 2. Imaginary part of z is equal to 3. Or we can also write this descriptive form as Re of complex number, which shows the real part of the complex number and imaginary part of complex number. All right. In mathematics, we know what is a set of real number. Set of real number is the largest number which contains all the numbers, like integers, like decimal, like fractions, means all the rational numbers and all the irrational numbers. When you combine them, you get a larger set, which is known as the real set. Real set also contains is one of the largest set which is known as set of complex. Like when we define any complex number, we also mention that individually real part and imaginary part both belongs to set of real number. So far, complex number is the largest set. This complex number allows us to solve equations that don't have solutions with the real numbers. That's what we have learned in our previous video, where we have learned that if we have square root of any negative number, then we can replace this negative number with iota square. This is what we learned, that iota is equal to root of minus 1, or if we take the square on both sides, then iota square is equal to minus 1. So this help us to reach our answer, which is 2 iota. Next is complex plane. A complex number can be represented on complex plane, where horizontal axis, which we normally call it as x-axis, represents the real part, and the vertical axis, which we call it as y-axis, represents the imaginary part. If we consider any complex number, let us suppose it is 3 plus 2 iota. So it shows that we can plot it by starting origin from origin and 3 unit right on x-axis 1, 2, 3, and 2 unit upward along the y-axis. So this is a number which can be written as 3 comma 2. In complex number we can show it like this. Okay, where 3 shows the real part. So as we said that x-axis will show the real part, but we can call it as a real axis. And y-axis is known as imaginary axis. So on right side of real axis, you can plot positive values. On left side of real axis, you can plot negative values. And along the y-axis, upward are the positive values and downward are with the negative values. So any complex number can be plotted in complex plane, and we can also write a complex number in form of ordered pair 3 comma 2. Next is a magnitude of a complex number. The magnitude of a complex number is the distance from origin on the complex plane. Just like this, if z is a complex number with 3 plus 4 iota, then we can plot this number just like this. 3 plus 4 iota means 3 unit along the x-axis, the real part, and 4 unit along y-axis, imaginary part, 2, 3, and 4. This is 4. So this is a complex number with 3 is the real part and 4 is the imaginary part. And magnitude of complex number is the distance from origin on the complex plane. Okay, so this is what we can find the length of this complex number OZ. You can see that if I show the vertical distance with dotted line, it looks like a right angle triangle. And if I mention along the x-axis, it is 4 unit, along y-axis, it is 4 unit. And z magnitude gives the length of this complex number. And when we apply Pythagoras theorem, then real part square and imaginary part square will give us the length of this complex number, and I can write its working directly. So it is 5 unit. So length of a complex number is equal to square of real part plus square of imaginary part, which is equal to 25. So it is 5 units. So in general, if we write a complex number which is in the form of x plus iota y, then z magnitude can be written as the square of the real part and the square of imaginary part will give us the magnitude. We can also say it like a real part square plus imaginary part square and then the square root. This gives the magnitude of a complex number. Okay, next concept is conjugate of a complex number. Conjugate of a complex number is obtained by changing the sign of imaginary part. Just like this, if z is a complex number with x plus iota y, and where we can say that x and y belongs to real number, and we need to find the conjugate. Complex number is represented by z conjugate. This implies that z conjugate is equal to x minus iota y. This is what I discussed. Conjugate of a complex number is obtained by changing the sign of imaginary part. So whatever the imaginary part has a sign, so you simply change the sign. Okay, let's move to the next thing. It is operation with complex number. Complex number, we know how to add the numbers or subtract the numbers or multiply the numbers or divide the numbers when all the numbers are within the set of real numbers. But when we consider the complex number, it is new to us, and we'll see that can we add to complex number or subtract complex numbers or multiply complex number or divide the complex number. So for this, I've considered two examples. The first example is for addition. Okay, when you look at in this step, you would see that 2 is without iota, so it is a real part. Minus 5 is without iota, so it is also real part. In addition and subtraction, real part will be added or subtracted with the real part, just like this. And imaginary part will be added or subtracted with the imaginary part. So it is 3 iota and plus 2 iota. Now, addition and subtraction is simple. 2 minus 5 is 3 and it is 5 iota. So you can see that by adding two complex numbers, we have obtained a result which is also a complex number. It means the procedure which we have followed is correct. You'll add the real part with the real part. You add the imaginary part with the imaginary part and then simplify. Okay, next is now we see particularly the subtraction. Same example, negative sign z2 is a number. Simple procedure when you open bracket, it change the signs, and you can identify the real part, write them together, and then the imaginary part, write them together, and do the simplification. It is 7 plus iota. So in subtraction, the resulting number is also a complex number because it is of the form of a complex number consisting of real part and imaginary part. Means now we learn how to add two complex number or subtract two complex number. Okay, next is multiplication of two complex numbers. Okay, so when we are going to multiply two complex numbers, we write them in brackets. And multiplication is very simple. Minus 3 minus 4 iota. These two will multiply with the brackets. And the next number is plus 3 iota. And same procedure will be followed and it will multiply with the complex number. Multiplication is simple, which is minus 6 minus 8 iota plus minus minus 3 iota will multiply with 3. It is 9 iota. But when you multiply 3 iota with 4 iota, then you write it as 12 iota square. So iota square is a term which we know that we can replace it with minus 1. So when you replace iota square with minus 1, you would see this minus will change the sign and 12 will be without iota. So it becomes a real part. So real part will be added with the real part. And imaginary part will be added or subtracted with the imaginary part. It is 12 and it is 17 iota. So the product of two complex number is again a complex number which consists of two parts, real and imaginary. So multiplication will be done like this. Next case is division of a complex number. So division of a complex number means we divide two complex numbers. See what will happen. Complex number has a particular way of writing, a real part and imaginary part. In this quotient form, you can see that you have real and imaginary part in numerator and real and imaginary part in denominator. But complex number is basically we write it as just like this. The real part plus iota and the imaginary part. This gives any complex number. Okay. Now we need to set this quotient form into single real part and single imaginary part. For this, we take the conjugate of the denominator and we multiply and divide with this conjugate. See, this is minus 3 minus 4. So it is minus 3 plus 4 iota. With the same conjugate number, we divide. In next step, we do the simplification. Simplification again involves in numerator multiplication, and in the denominator again it is the multiplication. In denominator, you can simply open the bracket and simplify it, or you can also use this result from the algebra where we have a minus b multiplied by a plus b, which means that one bracket is with negative sign, other bracket is with positive sign. So we can write it as a square minus b square. So this is the result which can be used in denominator. But in numerator, you can simply multiply two brackets. You can do it directly. 2 3 times minus 6 plus 8 iota minus 9 iota plus 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 and 12 iota square. This would be according to the identity minus 3 whole square, negative sign, and 4 iota square. This iota square will be replaced with minus 1. So I'll write it here. What is iota square? And this will be changed. 12 iota square will become minus 12, and 8 iota minus 9 iota will give you minus iota. In the denominator, it is 9 minus 16 iota square. which is equal to minus 18 minus iota divided by 9 minus and plus 16, because again we replace this iota square with its value, which is minus 1. Finally, we are moving to our final step. It is 25. So two numbers which are in the form of quotient can be written here: 18 over 25 minus 1 over 25 iota. You can see that this is single real part in quotient, and this is single imaginary part. So we have succeeded to write the complex number which are in the form of quotient into single complex number which contains single real part and single imaginary part. So whenever you can write any number in the form of iota b, so it is complex number. In case of division, we always try to remove the iota sign from the denominator. If you can remove this iota sign from the denominator, it means you have done the procedure and you will get your complex number. Let's consider a few examples regarding all these addition, subtraction, and multiplication, and particular for division, and see how can we apply these concepts to the questions. Okay, let's consider a question in which we have different parts, and this will give you the practice of addition, subtraction, multiplication, and division of complex number. So A and B part, you can see that these two parts are very simple. Although C part is simple, but let's discuss C part where we have 2r plus s. R is a complex number. You can take the value from the question, which is 3 plus iota, plus s is 1 minus 2 iota. So only difference in this part is 2 is multiplying with a complex number. So it's simple multiplication. You can do it like this: 1 minus 2 iota. So 2 iota is cancelled. So 6 plus 1, 7. So 2r plus s is equal to a real part. Although it is only a real part, but you can write it as a complex number by introducing 0 with iota. So you can write it as a complex number. So you can see that addition, the final answer is also in the form of a complex number. Okay. In D part, R plus SI. See, S is a complex number and it is multiplying with iota. So let's see what will happen. Although it's very simple, it is 3 plus iota, and S is a complex number with 1 minus 2 iota, and we write it in bracket and multiply with iota. In next step, plus iota minus 2 iota square, and iota square is equal to minus 1. So I'm going to change this iota square, this minus 1, and I'll write it 3 plus 2 iota. Iota square is minus 1, it is plus 2. So real part will be added with the real part. So final answer is this one. For F part where it is r square mean 3 plus iota whole square. Even you can apply the formula for square, or you can write them in two brackets and open the brackets. So both ways are possible. I'm taking the square of 3 plus iota. So it is 3 times 2, 3 square plus 2 times of 3 into iota and plus iota square. And as we know that iota square is equal to minus 1, so in next step, instead of writing iota square, I directly write minus 1. It is 9 plus 6 iota, and it is minus 1. So 9 minus 1 is equal to 8. So 8 plus 6 iota. So final answer is also in the form of a complex number. So this is how we get the answer. So these are the questions. You can pause the video here for practice, attempt all the parts. Okay, next concept. So far we have learned all the basics regarding the complex number. We know how to find the conjugate, how to find the magnitude of a complex number, how to plot the numbers on complex plane. Here there are some results which will be very simple. Like we have considered z is equal to x plus iota y and z conjugate is equal to x minus iota y. If you are adding number with its conjugate, any complex number with its conjugate, so you'll get 2x. What is x? A real part of z is equal to x, and imaginary part of z is equal to y, and a real part of z conjugate is equal to x, and imaginary part of z conjugate is equal to minus y. So you can see that this x is real part of z, which gives the result like addition of a complex number with its conjugate will be equal to 2 times of the real part of complex number. So this is the result. Okay, next is if we subtract number and conjugate x plus iota y minus x minus iota y, open bracket, x and x cancel, it is 2y of iota, which gives this result. Z minus Z conjugate is equal to 2 times of imaginary part of Z. Two complex numbers are equal if their real part and imaginary parts are equal. Just like this, if Z1 is a complex number with x plus iota y and z2 is another complex number with same real and imaginary part, we can say that z1 is equal to z2. Here we consider a question. Okay, in this example, we have given 2 plus iota multiplied by x plus y iota is equal to a complex number, which this equal sign shows that left hand side is equal to right hand side. Okay, the requirement of the question is we write two equation connecting x and y. So whenever you have this type of question, the first thing is simplify left hand side completely. 2x plus, this becomes the real part, 2x minus y, and imaginary part mean when you take iota common, so you're left with this. It is 1 plus 3 iota. See, with this equal sign on the left hand side, this complete bracket is without iota, so it's a real part. Next bracket is with iota, so it's a coefficient of iota, so we call it as imaginary part. The first thing is we need to write two equations. So when we compare, so the first part of the left hand side will be equated with the first part of the right hand side. So this is first part of right hand side is 1. So real part is equating with the real part on the other side. This is equation number 1, and the other is imaginary part of left hand side is equal to the imaginary part of the right hand side. So these are the two equations. The next thing is these are the two equations. If we need to find the values of x and y, you can get the values by solving 1 and 2 simultaneously. But the requirement of the question says we need to compare with that given by dividing 1 plus 3 iota by 2 plus 3, 2 plus iota. If I write the question again, question is 2 plus iota, it is x plus iota y equal to 1 plus 3 iota. So the requirement of the question says we simply need to write it in this form, 2 plus iota. Now we have complex number in the denominator, then we take the conjugate of the number and multiply and divide. So numerator will multiply, so I'm doing it directly. 1 will multiply by 2 minus iota plus 3, 2 the 6 iota plus minus minus. It is 3 iota square divided by, okay, iota square is minus 1. So this term will become plus 3. So I'll write it 2 plus 3 and plus 5 iota, and in the denominator I have 2 square 4 minus iota square. It is 5 plus 5 iota. In the denominator it is 4 plus 1. So x plus iota y is equal to 5 plus 5 iota. So divided by 5, so we can divide it separately, which take us to the answer x plus iota y is equal to 1 plus iota. This implies that x is equal to 1 and y is equal to 1. So this is how you solve the equation. The concept of solving equation where complex number are equal, when you simplify the equation, you need to equate the real part on both sides and imaginary part on both sides. So that's it for this lesson, and we explored the basic of complex number from their form and representation on the complex plane, and we learn how to perform the operations addition, subtraction, multiplication, and division. Complex number are an essential part of mathematics, and understanding them will unlock many new possibilities in problem solving. Thank you for watching this video. If you enjoyed it, please like, share, and subscribe to the channel. Don't forget to hit the notification bell so you can stay updated with our latest lesson. Keep practicing, and I will see you in the next video. Take care.